But hear me out though, right? Because, like, why don't we just build telescopes on beaches? Because you could put it just in the middle of the ocean on an island and you'd be miles away from light pollution. Like, just pick an island in the Maldives and build a telescope and we'll be set. Because I'd be lying if I didn't admit that one of the best perks of the job being an astrophysicist is getting to travel to far-flung places to use a telescope to take the data you need, like the middle of the desert in Chile or Australia or Arizona. But while the desert is cool, I am an ocean girly. I was obsessed with both space and dolphins as a kid. I very nearly became a marine biologist. So when I'm here in the Maldives at resorts like Soneva Fushi and Soneva Jani, this is a perfect paradise to me. I can dive and snorkel during the day and then enjoy the resort's amateur telescopes at night, which are an absolute treat.
So why don't we have professional astrophysics telescopes in places like this?
Why are the next generation of massive telescopes like the Rubin Observatory and the extremely large telescope both being built in the high altitude Atacama Desert in Chile instead?
You know, there's no dolphins in the desert. Sad times. Well, unsurprisingly, they're not built at beaches because it doesn't give us the best scientific data. So, instead, for a professional observatory, there's a few things you need.
The first is low light pollution. The second is good weather. The third is low humidity. And the fourth is a thin atmosphere.
So yes, while putting a telescope on the beach, on an island, in the middle of the ocean gets you away from light pollution, it gives you gorgeous weather with clear skies, it definitely doesn't give you a thin atmosphere, and the humidity is definitely not on your side. So let's go through why each of these things on this list is important, starting with the first there.
Low light pollution, which is incredibly important because otherwise you wash out the night sky. We're all familiar with how few stars that you can see in cities. The street lights and the lights from people's homes combine to give you just a general glow in that area, making the sky brighter and washing out the fainter objects like faint stars, galaxies, and nebula. This is a big issue for some professional observatories that were built a long time ago, but since then the nearby cities have spread. For example, the Lick Observatory in California up on Mount Hamilton is just outside both San Jose and San Francisco. If light pollution gets worse, then that observatory will no longer be able to obtain good enough quality data to do science. Next up on our list is good weather. I'm sure you've all noticed how dark and grey it can get when it's a very cloudy day. Clouds of water vapour reflect sunlight back into space, so less light makes it to the ground. And if clouds can stop that much light from the incredibly powerful sun, then faint starlight from thousands of light years away hasn't got a chance. Never mind light from a galaxy billions of light years away. So picking a location that has a high percentage of clear nights is also incredibly important for an observatory. But even if there's no clouds, there's still the issue of humidity.
And it is here where my dream of a beach observatory definitely comes to die.
Big globs of water vapour in the atmosphere can scatter light, making the sky look really hazy. So next time you're by the sea somewhere that's humid, notice how there's not much to see at night in terms of stars at the horizon, where you can notice this effect more. This is why people pick desert sites for observatories, so the air is drier. But specifically ones at high altitude as well, so that you also have a thin atmosphere.
You know the famous children's song, Twinkle Twinkle Little Star, which, yes, okay, looks absolutely gorgeously romantic while you sat on a beach, but to an astronomer, it is our absolute worst nightmare.
Twinkling is caused when light gets distorted as it passes through the atmosphere. So a warmer patch or a cooler patch or a denser patch of air are all going to slightly change a light ray's path through the atmosphere to the ground, spreading out that light, which is going to smear the image you're taking. This is why going to space with a telescope is so great, because it removes all these problems entirely, but especially sharpens your images because you've gone to the thinnest atmosphere possible. That's expensive though, so for observatories on the ground, we go to high altitude instead. Now, even at high altitude, there is still some atmospheric distortion of light, and a lot of professional observatories now have what's known as adaptive optics, where they fire a huge laser into the sky, which, because it's a laser, should give an image with a nice, crisp dot, but the atmosphere blurs it out. So by recording what happens to the laser dot, we can then cancel out those effects on the light from the astronomical object that the telescope telescope is observing and take into account some of the twinkle-twinkle effects of the atmosphere. This can't save my beach observatory dream though, sadly, because this gets harder and harder to do the more atmospheric distortion you have. So if you can minimise it by going to high altitude first, then you have a better chance of being able to correct for it using what we call adaptive optics.
So there you have it. A beach observatory is just not gonna cut it, sadly.
Which is why the observatory in Hawaii, which sure is in the middle of the Pacific Ocean, away from light pollution, is also 4,000 meters above sea level on the top of Mauna Kea to get above the clouds and the humidity that you find at the beach. And while I could realise my dream if I just commuted up and down every day from beach to telescope, for most observing runs you're working 12, 14-hour night shifts at high altitude where the air is thin, and that is sadly a cocktail for exhaustion.
So while my dreams of a professional observatory out here in the middle of the ocean are sadly never going to happen, it is still great to be here at Soneva Fushi and Soneva Jani in the Maldives to enjoy their observatories under these incredible dark skies. While I'm here, I'll be giving stargazing tours of the night sky to guests in the resort, and it is all thanks to all of you at home that keep watching my videos that I get to have experiences like this in the first place. So a huge thank you from the bottom of my beach-loving, clear sky-loving, sushi-loving heart for continuing to watch and support my channel. And all that's left for me to say is happy stargazing. So why don't we have... Itchy McItchison. So ungraceful. Definitely not on your side. So let's go through. You through? Damn it.
Yeah, that's still getting that little star. Sort of. Is it focusing on me? Yes. Okay. There's one star in shot and it's behind a fecking cloud. Why? I need a wider lens. My top does not look blue in this light. On the camera anyway. Colour theory, eh?